Hello, so I just took an organic chemistry test, and this was one of the problems that I had. It was turning bromobenzene into this weird, what's it called, ester group here with a phenyl ring, and it's a really interesting problem, and I looked at it for quite a while, and it was design and a synthesis, but not an efficient one. Now, I spoke to the professor, and she said that there's a faster way to go about this than I did, but she didn't specify what, of course, because that would be cheating. But I'm curious, how in the world would you get this faster? So my thought process was, well, I first did a little bit of retrosynthesis, I said, and I'll actually move this over since I have this space. I thought retrosynthetically, and I said, okay, well, to make this here, it's really weird how this is positioned, right? Because it looks like you would have to do some sort of carboxylic acid chemistry. But here we're kind of starting from the benzene side, and it kind of confuses me a little bit. So what I thought is, okay, well, to make this, I could make it from something with a leaving group here, right? If I used like a basic species, I could attack the leaving group, kick it out via an SN2 reaction, and form that compound there. Okay, so that's kind of the thought process I had retrosynthetically, but the idea was, how do I get a leaving group here? That was kind of my question. I asked myself, so I'm gonna erase this here, but that's kind of the thought process I went in with this question, or to solve this question. That's kind of what I went through with this. And I thought, without doing any weird aromatic reactions, it's really hard to change out a group here on this benzene ring, right? Because if you add certain nucleophiles, it's not going to want to do SN2. There's too much steric hindrance there, too many electron repulsions. These aromatic compounds with groups, they're not just leaving groups, right? They're really stabilized, right? The bromine will have resonance with the ring, so it's just a really, really weird situation. And I'm not too familiar with a lot of the bromobenzene reactions. I only know, like, how can you add things onto benzene. So with that knowledge, I kind of said, okay, well, the only reaction that I could really do here that makes sense to me is maybe do a Grignard. So make a Grignard with magnesium metal and diethyl ether, right? And that would make a Grignard. So I thought, okay, well, now I have a tool that I can use, right? I have a Grignard of the bromobenzene, and it's like, okay, it's okay. So then I thought, well, if I want to extend out a carbon, I could attack a CO2 molecule, and I could form a carboxylic acid, but that would take a long time. But when I looked around and tried to think of other things that could attack with the Grignard, I really couldn't think of anything. Like, in my head, I have a theory that if maybe you used COCl, not sure that molecule would exist, but let's just say it does, right? Instead of CO2, right? The carbon would have a negative charge. It would not be happy. But let's just say this existed somehow. Or maybe it could be like that, and it could attack, and then go right to our acid halide. But I was just saying, I'm gonna play it safe. I'm not gonna throw bullshit out of my ass. I'll just say CO2 as our first step, and then we're gonna follow it up with an acid workup because we're gonna get a carboxylate. We wanna get a carboxylic acid, so we're gonna use H3O plus as a workup. So I finally got out that one carbon so we can start to form a leaving group. I was like, okay, this will need to convert because we can't simply just use something to get no, because if we use lithium aluminum hydride directly, it's going to rip off the hydrogen. So we need to make this into an acid halide first, a more reactive species with no acidic protons. That's kind of where I went here. And then I said, okay, now we can use lithium aluminum hydride in our first step, and then our second step, an acid workup. Okay, and then we get this here. where we get a leaving group. Okay, now it kind of was similar to that idea that I had at the beginning where I want to make a leaving group. That's kind of where that OH comes in. I could do either SN2 to get a better leaving group, like with an iodide, sodium iodide. I could use enforcing conditions to make that happen. I could, well, it would be really hard to do that actually, but what I ended up doing is I said, okay, I'm first going to protonate with acids. So I said H3O+. I'm going to protonate with acid, so this thing gets protonated. And then I said, what if I use the corresponding alcohol, or sorry, the corresponding carboxylic acid of that ester, right? So I said that we are going to protonate this and then attack it, right? Just by chance this thing attacks it, gets deprotonated, and then it's just connected on for life, and that would lead to our product. But this step specifically seems a little unlikely to me. I can't really tell you why, but it just doesn't feel right. And you would get your product, but that's only in theory. So I'm a little on edge about if I got this question right or wrong. I really can't think of any other reaction that could extend this. Maybe we could use some sort of, like if we did I know that if you use, what's it called, a cyanide nucleophile, it will substitute, so maybe you could do that, and then you could lead downfield to, because now you have the carbon there, but how would you make this a leaving group really? Because I know if you make it NH2 with well, you could go through hydrolysis again and get right to the carboxylic acid. That actually might cut out some of this, which would be good. But I kind of like the idea of making a really strong electrophilic species attack a CO2 molecule. To me, and these reagents are easy to come by. KCN maybe not so much. And if I was in a lab, I'd be a lot happier working with magnesium than something that could fucking kill me. But you know, that's just me. So yeah, I'll just leave it at that. That this is my synthesis, but I'm curious in the comments if anyone has an alternative synthesis that you want to leave in the comments. I greatly appreciate it, and kind of give your rationale for why. Thank you very much for watching. Have a wonderful day.